Hello everyone. So this is a question from JEE Advanced 2026 paper 2. You can pause your screen and go through the question. The chapters involved is solutions and equilibrium. So I will quickly write down the things that are given to us. Okay. So we have, let's say we have a container, and in that the solvent is S and the solute present is B. Okay. And the solute in the solvent dissociates in this fashion to give us 2C plus 2D. Okay. And also it is given to us that B, C, D are non-volatile. That means their boiling point is high. That is, they don't become vapor easily. And it is also given that molar mass of B is 10 times, that is 10 into molar mass of S. So I can also write M of solute is equal to 10 times M of solvent. Okay. And for the solvent S, the boiling point, let's say that is TB naught, is given to us as 400 Kelvin. And also the standard enthalpy of vaporization, that is delta vaporization H naught, is given to us as 10 R joules per mole. Okay. Also, in a solution of B in S, the concentration of B is 0.25% mass by mass. Okay. So therefore the mass of B will be 0.25 gram, and obviously since it is mass by mass percentage, so mass of solution will be 100 gram. So therefore mass of the solvent S will be equal to 100 minus 0.25, that is 99.75 gram. Okay. And also for this solution of B in S, the boiling point of the solution, let's say that is TB, is given to us as 408 Kelvin at 1 bar pressure. Okay. So we know that delta TB is equal to I into KB into M, right? Where delta TB is elevation of boiling point, which is one of the colligative properties. I is the vent off factor. KB is molal elevation constant, and M is the molality of the solution. Okay. We should also know that boiling point of solution is always greater than boiling point of the pure solvent. Okay. So therefore I can write delta TB is equal to TB minus TB naught, right? So this TB is the boiling point of solution, which is given to us as 408 Kelvin. This TB naught is the boiling point of pure solvent, which is also given to us as 400 Kelvin. Okay. So therefore delta TB will be equal to 408 minus 400, that is 8 Kelvin. And since B is dissociating, if you remember, yes. So therefore I, that is the vent off factor, will be equal to total number of moles of particles after dissociation divided by total number of moles of particles before dissociation. Okay. So let's assume the initial number of moles of B is N. Initial number of moles of the solute B is N. and its degree of dissociation is alpha. And we know that from equilibrium that degree of dissociation alpha is total number of moles dissociated divided by total number of moles initially taken. Okay, and our aim in the question is to calculate mole percent of B that has dissociated. Okay, and if you look carefully, the mole percent of B that has dissociated is nothing but alpha into 100, because the fraction of B that has dissociated is total number of moles dissociated divided by total number of the moles that I have taken initially for B, and when you multiply that by 100, then we will get the mole percentage of B that has dissociated. So our aim is to calculate alpha into 100, and it is given to us that B dissociates to give 2C plus 2D, and we have assumed initial moles of B as N. So therefore N 0 and 0, so this is at time t equal to 0, and at time t equal to equilibrium, when we have achieved equilibrium, we'll be left with N minus N alpha, 2N alpha, and here also 2N alpha. Okay, so since alpha is the degree of dissociation, so alpha is number of moles of B that has dissociated divided by number of moles of B that I have taken initially, that is N. So therefore number of moles of B that has dissociated is N times alpha. Okay, so this is nothing but N alpha. So this is the number of moles that has dissociated, and I started with N. So therefore at equilibrium I'm left with N minus N alpha. Okay, and you can see 1 mole of B gives 2 moles of C. So therefore N alpha of B would have dissociated to give me 2N alpha of C. Similarly, you can see 1 mole of B gives me 2 moles of D. So therefore N alpha moles of B would have dissociated to give me 2N alpha moles of D. Okay, so therefore I can write I as number of moles of particles after using this formula, number of moles of particles after dissociation divided by total number of moles of particles before dissociation. So after dissociation we have N minus N alpha plus 2N alpha plus 2N alpha, and before dissociation we just had N moles of B. So therefore I will be equal to 1 minus alpha plus 2 alpha plus 2 alpha, so which will be equal to 1 plus 3 alpha. Okay, now we have to calculate Kb because the solvent is not mentioned. Okay, we know that Kb, the molar elevation constant, is equal to M solvent into R into Tb naught square divided by 1000 into delta vaporization of H naught. Okay, so in this formula, M solvent is the molecular mass of the solvent, Tb naught is the boiling point of pure solvent, R is the gas constant, delta vaporization H naught is the standard enthalpy of vaporization of the solvent. Okay, so inserting the values, M solvent we don't know, into R into the boiling point of pure solvent is given to us as 400 Kelvin. So 400 into 400 divided by 1000 into standard enthalpy of vaporization of solvent is given to us as 10R. So R and R gets cancelled, 20 4 zeros, and here also 4 zeros. So we are left with, so therefore Kb will be equal to 16 times M solvent. Okay, So coming back to the OG equation that we started with, that is delta TB is equal to I into KB into M. So I know delta TB, that is 8. I calculated I is 1 plus 3 alpha. I calculated KB, that is 16 times of M solvent, into molality will be equal to N divided by 99.75 divided by 1000. Okay, so this is the number of moles of solute, and this is the, in the denominator we have mass of solvent in kg. Okay, so 8 will be equal to 1 plus 3 alpha into 16 times of M solvent into number of moles of solute is given mass by molar mass. So given mass of solute is 0.25 gram divided by molar mass of solute, I don't know, into 1000 divided by 99.75. Okay, in the question it is given to us that M of solute, that is B, is equal to 10 times M of solvent S. So I can insert this value of M solute here. So this will change to 10 times of M solvent. Okay, so therefore, this and this gets cancelled, and this 10 and this 100 gets cancelled. So therefore, when we bring all these guys towards the left, I'll get 8 into 99.75 divided by 16 into 0.25 into 100 is equal to 1 plus 3 alpha. Okay, when you do this calculation, you will get this as 1.995, that is equal to 1 plus 3 alpha. So therefore alpha will be equal to 1.995 minus 1 divided by 3. Okay, so after doing this calculation we get alpha as 0.3316, and our aim is to calculate alpha into 100, so it will be equal to 33.16. So therefore the mole percentage of B that has dissociated is 33.16%. Okay, so the final answer is 33.16%. Okay, thank you.